So good afternoon. My name is Seymour Spence, and I am an associate professor here at the University of Michigan. So welcome to the University of Michigan Building the Future Distinguished Lecture Series. So in 2017, we kicked off the strategic visioning process. And in 2019, we completed our strategic vision, which includes 5 strategic directions: adaptation, shaping resource flows, autonomy, smart infrastructure finance, and human habitat experience, which is the focus of today's presentation. This is an exciting focus for our department and the profession as a whole. This vision reaffirms our value proposition to our communities and reinforces our commitment as engineers working in service to society. Our Building the Future lecture series focuses on highlighting our plan. This virtual lecture series provides a forum to discuss each strategic theme. It aims to build a broad community network that includes industry professionals, researchers, educators, and students. Through presentations from leading experts and panel discussions that provide new insights, this series explores a range of perspectives on the 5 strategic directions. We have had a lot of support to make this vision and today's presentations come together. We would like to especially thank our co-sponsors for today's event, the ASCE EMI Objective Resiliency Committee and the Taubman College of Architecture and Urban Planning. I'd also like to thank the Strategic Implementation Committee led by Professor Shannon. During today's session, I will serve as the panel moderator. We want to make our event accessible to all participants. This webinar will have live automated captions and the transcript will be available. To choose a viewing option, click Live Transcript on the control bar at the bottom of your screen, where you can show or hide the subtitles or view the full transcript. So today's lecture emphasizes the strategic theme of human habitat experience. To give an overview of this theme, I would like to play a 2-minute video. Michelle?
Civil and environmental engineering historically have had enormous impacts on the way in which people live their lives. We're focused on all human life. It is global, it is wide-reaching, given the broad impact that civil and environmental engineers have around the world. By referring to the habitat experience, the idea is that we are engaged in improving all aspects of the environment in which humans live, work, and play. We have a number of faculty, Nancy Love and Jerry Lynch, where their projects are specifically designed to go out and engage the public at the very start with the solutions that are being proposed and even bringing the public into the data collection process. We have multiple research projects here looking at ways to make sure that specifically the indoor air is maintaining healthy conditions in residential and commercial spaces. Research that I do focuses on making sure that airborne pathogens don't live very long if they're emitted into the air. There's also research being done where we're using wearable devices to better track not only human comfort, but better track human activity, human safety in construction environments. All of these are ways in which we can personalize the experience to maximize comfort, maximize safety. There is so much more expectation from the public, and as engineers, if we aren't responsive to that, then we are not doing our job.
During the lecture and panel discussion, I invite participants to send in your questions using the Q&A function. We will try to get to as many of your questions as time allows. Now I would like to introduce our very special speaker and panelists. We're very fortunate to have Elizabeth Fussell, professor at Brown University, who will speak to us on climate change, disasters, and migration systems, a research agenda. The presentation by Beth will be followed by a panel discussion with 3 distinguished panelists, Ses Guykamar, Pam Jenkins, and Liz Maley. Ses Guykamar is a professor and co-director of the Center for Risk Analysis Informed Decision Engineering at the University of Michigan. Pam Jenkins is a professor emeritus at the Center for Hazards Assessment, Response and Technology at the University of New Orleans. And Liz Maley is an associate professor at the International Research Institute of Disaster Science at Tohoku University. This brings us to today's distinguished lecture. Let me now invite Bess to speak to this theme and give her presentation. So Bess, the floor is yours.
Thank you, Seymour, and thank you to everybody in your department for inviting me to be part of this lecture series. It's really an honor to be with you. Let me get my slides going. All right. So in January, I listened to Bas Jonkman's talk in this series on adaptations to sea level rise in Holland. And I was struck at how the theme of coastal retreat often came up in the discussion as a solution when in situ adaptation is no longer feasible. My presentation today will pick up on that thread of the discussion to consider what we already know about migration response and responses to extreme weather events related to climate change. And yes, there are already measurable migration responses to disasters that can be studied scientifically to identify the mechanisms and possible points of intervention that may move people out of harm's way and improve the human habitat experience. When Earth scientists project the effects of climate change on human migration, they estimate the number of coastal residents who will be displaced by coastal inundation at some point way off in the future. So this image from Climate Central uses this exact method to project future coastal flood threats in Dhaka, Bangladesh, using remote sense elevation data and grid level population data. These images help us to imagine the future. However, this approach always makes two classes of assumptions. First, it assumes that there's no adaptation, whether those adaptations are hard or soft protection against flooding and cyclone damage. And second, it assumes that population growth will continue at the same rate without changes in migration behavior. These assumptions are a black box that civil engineers and social scientists are currently opening up to make critical contributions to the understanding and promotion of human adaptation to climate change. I study hurricanes and their effects on human populations because hurricanes occur at a large scale, which generally spans counties, and therefore their impacts are more easily observable in population data, which is readily available at the county level. In my research, I asked three basic questions. First, do hurricanes cause changes in population size, which are driven by changes in migration patterns? And while we know that this may happen in some instances, such as what we saw in New Orleans after Hurricane Katrina, we also want to know whether that was the exception or the rule. So we can ask a follow-up question. Are there generalizable effects of hurricanes on migration patterns? A second question is, if hurricane-related disasters cause migration, where do those migrants relocate? And then finally, the third question is, who is most likely to move because of a hurricane-related disaster? There are significant challenges to answering these questions that I'm going to review very briefly here. First, migration is actually really hard to measure. We typically measure it with censuses and surveys. In the US, we use the American Community Survey, which is a population sample of about 2.3% of the US population. But that survey data is too sparse to easily connect with a geographically concentrated event like a hurricane. And so we can't really use it only in the most extreme cases can we use it to measure disaster-related migration. But we can also measure migration with administrative data that's more comprehensive geographically and of the US population. the shortcoming of administrative data is that it doesn't measure individuals' demographic characteristics. So we don't learn very much about the people who are moving. So that's a trade-off between data sets. Can we even can we measure geographic coverage, or can we measure characteristics of the population? And this trade-off was particularly relevant in the study of disaster-related migration, since disasters generally affect small geographic areas, and they typically only a small proportion of people move because of a disaster. And that's a good thing, because we don't want a lot of people moving because of disasters. The research I'm presenting today uses the data that is available to answer these questions to the greatest extent possible. While we can think of a few instances in which hurricane-related disasters have caused large migrations, there are many more instances in which there is no migration response after a hurricane. Yet we hear about the looming threat of climate migration in news headlines, so this is clearly a question that needs answering. Hurricanes are becoming more destructive as the ocean warms and sea levels rise. This map of the US from the US Geological Survey shows red dots in places where vulnerability to sea level rise is very high. Hurricanes in these areas have already proven to be more destructive in the last 2 decades than they were previously. For example, in 2005, Hurricane Katrina struck New Orleans, breaching the levees that protected this below sea level city. Floodwater reached the rooftops in the lowest elevation parts of the city and covered 80% of the land in Orleans Parish. It took 6 weeks for the floodwater to be pumped out, and the entire population of 500,000 residents evacuated either before or after Katrina made landfall. Of course, New Orleans isn't the only place that was affected by Hurricane Katrina. Other parts of the Louisiana and Mississippi coast were hit by a storm surge that destroyed and damaged housing and the built and natural environment as far as 6 miles inland. About 850,000 homes on the Gulf Coast were damaged or destroyed, and damage to housing and infrastructure displaced the residents of more than 1 million Gulf Coast residents, many for well over a month and some for much longer. The FEMA estimates the direct damages of Hurricane Katrina to be about $125 million, which makes it the most costliest hurricane disaster in US history. In addition to the housing damage, jobs were lost when business capital was destroyed and demand for goods and services declined. The Bureau of Labor Statistics reports that nearly 300,000 workers were laid off after Hurricane Katrina. The loss of housing and employment forced many residents to relocate, at least temporarily, if not permanently. And we can see this effect on population in this slide about on the population of New Orleans metropolitan statistical area. There are 9 parishes in the metro area, and this shows their population, their mid-year estimate of the population in each year from 2000 through 2019. So 2 things should be noted from this slide. In Orleans Parish, which is the line in orange, and of course, Orleans Parish is the central city of the metro area. The mid-year population fell by more than 50% between 2005 and 2006. Declines are also evident in St. Bernard and Jefferson parishes, which are the yellow and blue lines respectively. The inland parishes of the metro area did not see the same kinds of losses, and some, like St. Tammany or Tangipahoa, actually experienced some population growth as residents relocated within the metro area. These losses between 2005 and 2006 were to varying degrees offset in the subsequent years when the flooded parishes, particularly Orleans Parish, achieved record annual population growth rates. But none have actually returned to their pre-Katrina sizes. So is this the exception or is it the rule? Hurricane Harvey vies with Hurricane Katrina for the most costly hurricane in US history. Harvey was a slow-moving tropical cyclone that dumped 40 inches of rain on Houston and the surrounding areas of Texas in just a few days in late August 2017. It also caused the $125 billion in direct damages, but unlike Hurricane Katrina, the rainwater and the floodwater flowed out of the city within a few days. Homes were damaged, but people were not as displaced not as many people were displaced, and those who did move away didn't have to stay away for quite as long. And job losses were temporary for the most part. So when we look at the same kind of population slide, growth rate for Houston over the same period of time, we don't see the kind of dramatic changes that we saw for the New Orleans metro area. In other words, the relationship between a massive flooding event and population displacement is not direct. The duration of the event, the type of damage incurred, population losses, and the amount of resources devoted to the recovery, as well as the pre-disaster population growth trend, all make a tremendous difference in how post-disaster recovery of population unfolds. So this prompted me and my colleagues to ask a different question about whether there are generalizable effects of hurricanes on migration. We assembled a data set of county population sizes for all years from 1970 through the latest year available to make valid statistical generalizations about hurricane effects on population for every county that has ever been exposed to a hurricane during that period. My collaborators on this project are Sarah Curran at University of Washington and Jana Johnson at University of Minnesota. This map shows all the US counties that ever experienced a hurricane during that time. And we just ignored those West Coast counties, which were different type of wind events. So then we combined that population data with data on hurricane events from the Spatial Hazard Events and Losses database for the US. And we looked at population change for each county in each year for 5 years before and up to 20 years after a hurricane event. Using a difference in difference model with controls for population density, population size, and economic growth, we estimated this model, a logistic regression model. And this analysis shows that on average, a county exposed to a hurricane experienced a 0.1% decrease in population relative to its baseline trajectory in the first year after a hurricane. In other words, if a county had been growing, it grew slightly slower than it otherwise would have. If a county had been declining in growth, it declined faster than it otherwise would have. The suppressed growth persists over the long run, resulting in population growth that is 0.6% lower at the 10-year mark and 1.15% lower at the 20-year mark. What's most interesting for me about this analysis is that when the county year data are subset by the number of hurricanes the county ever experienced during this period, we find a statistically significant difference in hurricane effects. Hurricane exposure did not suppress population growth in counties that experienced 7 or more hurricanes between 1970 and 2017. So that's represented by the blue line, which is basically the same as the baseline trajectory. Hurricane exposure does suppress growth in counties that experienced between 1 and 6 hurricanes during this period. This suggests that counties that experience frequent hurricanes have already adapted to those exposures, preventing population losses. Where hurricanes are more rarely experienced, people are less prepared. So to summarize, while hurricane exposure does tend to suppress population growth in general, there's variability among the counties that merits further investigation. The second question is, where do hurricane-affected migrants move? And in contrast to the county level analysis of population change, this question, we use data that focuses on individuals and their migration behavior as it scales up to county migration flows. To find out where hurricane-affected migrants relocate, my colleagues Jack DeWard and Catherine Curtis and I have focused on Hurricane Katrina and its effects on New Orleans population, because that event caused so much migration. We can see from FEMA applications for individual assistance after Hurricane Katrina that evacuees could be found in every state. And we wanted to know whether the distribution of Hurricane Katrina migrants was predictable in some way. So we put together a migration systems approach to look at this county migration flow data. I'm going to try to really briefly describe what this data looks like. So a migration system is the entire network of places connected through migration flows, and it can be measured by this matrix of all counties connected by migration. You can see in this toy example that the counties on the diagonal, those are the non-movers, the cell counts there are the non-movers, and on the rows and columns, you have the movers. And these are measured by comparing 2 years of administrative data that has the current locations of individuals. And we can compare those 2 years of data to see whether the addresses in both records are the same or not. And if they're not, then we look at which counties are connected through that migration. We aggregate these up to create the data that we use for this analysis. In this case, we're using data that's been assembled by the Internal Revenue Service using tax filings. So a qualitative approach to analyzing the migration systems data would involve listing all of the out-migrant destinations in each of the 3 periods under consideration: the pre-disaster period, the disaster period, and the post-disaster period. But doing that is a little bit daunting. So I'm not going to review these lists. Rather, I'm just going to point out in the last 2 rows that you can see the total number of counties connected in each of these periods grew from the pre-disaster period, it quadrupled to in the disaster period, and then shrank back down in the post-disaster period. We can also see this with maps. This is much more comprehensive way of looking at the data. You can see the pre-disaster tide counties where the darker counties indicate larger flows. I'm just going to go through these so that you can see quickly how much the system grew during the disaster period, which you see here. And that larger, more distant counties received larger numbers of out-migrants. And then here you see the post-disaster period where it shrank back to its pre-disaster size. These statistics can be summarized in this table. And I think I'm gonna, in interest of time, just focus on one measure that I think is really interesting. And it's this in the middle of the table, the Shannon entropy index, where an entropy index measures kind of the predictability, or maybe, and put another way, the uncertainty with which we can predict where people are distributed in this system. What we see here when we standardize the entropy index is that we get a summary measure of, in the ratio of the observed entropy to the maximum entropy, of how the system expanded and then shrank back down to its pre-disaster size. The other thing that in the lower panel of this table, you can see that I've decomposed the migration system into stable elements and changing elements. The stable elements are all the counties that were connected throughout the entire period. And what I want to call your attention to is that these elements, the migration flow sizes of these elements were always very large. But look at how between the pre-disaster period and the disaster period, the average flow size in a stable county-to-county flow system increased by on the order of 10, from 192 to over 1,000, and then it shrank back down. The change elements, the counties that were added or subtracted from the system had much smaller average flows. We can do the same exercise for the in-migration element or dimension of the migration system. But I also want to move quickly through this. The main point is to see that the way in which the in-migration system changed is that in the pre-disaster period, from the pre-disaster period to the disaster period, the system shrank with fewer counties connected through smaller migration flows, but it really grew in the post-disaster period. And that is how New Orleans recovered its population. So you can see those 3 stages here too. Again, with the summary table, what's really interesting is how we can summarize these changes in the migration system by looking at the entropy index as well as the size of flows in the stable system elements and the changing system elements. So the stable system elements grew the most in the post-disaster period. Those were clearly the pathways by which migrants returned to New Orleans. So my colleagues, Jack DeWard and Catherine Curtis, and I used this approach to study the recovery migration system of Orleans Parish, and we made several conclusions about it. We found that the migration system spatially concentrated and intensified the flows following the same pathways that connected the pre-disaster outflows with the post-disaster return flows. And the other observation was that the urban counties were particularly important in being a sort of a holding cells for the displaced population who then returned to New Orleans. So we've used the migration system approach to really learn a lot about how New Orleans recovered its population, but there's a lot more that we can still do. So in current NSF supported research, Jack and Catherine and I are looking at the effects of other environmental shocks like tornadoes and wildfires on migration systems to see if we observe similar or different patterns. This type of research begins to fill a gap in our understanding of when and where environmental shocks produce large-scale migration responses, and whether and how disaster-affected places recover their populations through a migration system. The third question, who is most likely to move because of a hurricane, is actually, it hasn't yet been answered with the migration systems approach. This question is really difficult to answer using migration flows data. In fact, it's impossible because we don't yet have the data that can be decomposed by demographic characteristics such as age, gender, race and ethnicity, educational attainment, or anything else. In a new NSF project, my colleagues and I are building a new migration flows data that will be more comprehensive of the US population and decomposable by broad demographic characteristics. The data set doesn't yet exist. So in this section, I'm just going to review briefly some of the evidence we have from Hurricane Katrina about racial inequality and disaster-related migration. As you already know from my previous slide, a lot of people were displaced from New Orleans by the flooding of the city. Remember that the city is surrounded by levees, which protect the city normally, but in this case, and what made Hurricane Katrina so devastating is that the levees failed. And when they failed, the city filled up with water. So on the left panel, what you see here is a flood map, a NOAA flood map from August 31st, 2 days after Hurricane Katrina passed, where the flood depths were as high as 12 feet in many low-lying parts of the city. Those flooded areas are represented by the green, yellow, and orange colors. The purplish colors are the unflooded parts of the city, where the land was dry, and then of course these deep blue areas are water bodies. But you'll notice that the unflooded portion of the city is what we call the sliver by the river over here. And this is where the natural levee that was there when the city was first settled was continually reinforced by the Army Corps of Engineers. And that's where the French Quarter and the Garden District and the uptown neighborhoods are all located. Homes in these neighborhoods are older and tend to have higher property values. And residents of these neighborhoods are disproportionately white, although the majority of the city's population is African American. The flooded areas of the city are sometimes referred to as the back of town neighborhoods. And these are in the center of the city where the elevation is the lowest, and areas close to Lake Pontchartrain on the north, and then also the east of the city where reclaimed swampland is protected by levees. Historically, these lower elevation neighborhoods with greater flood risk were more affordable to working class residents, including many African American residents. Redlining, residential segregation, and exclusion of Black residents from suburban parishes in the 20th century reinforced this racialized settlement pattern. So the panel on the right shows that 52% of housing units in Orleans Parish were severely damaged, mainly by flooding. And these housing units sheltered 55% of the population. The historic settlement patterns that I just described meant that a disproportionate number of these flooded housing units were homes to African American residents. And there's ample evidence that Black residents were displaced in greater proportions and for longer periods than non-Black residents of New Orleans. And this is part of the reason, although not the entire reason, the reason for this was partly because of the disproportionate exposure to flooding, but there were other reasons as well, which I'm not going to go into right now. But my motivation for the new data set of migration flows that allows for decomposition by demographic characteristics is that it would allow us to discern distinct features of the migration system. For example, we could discover whether the migration system of the Black and non-Black residents of New Orleans differed in terms of which counties they were tied to, and how these places are associated with different types of environments or resources and amenities. So the database would allow us to see not only who moves after a hurricane, but how their age, sex, race, ethnicity, or other demographic characteristics are related to their destination. Ultimately, the goal of this research agenda on disaster-related migration is to develop actionable findings and improve the human habitat experience, especially as we worry about climate change effects on our environment. The main point I'd like to leave you with is that a migration systems approach can provide actionable insights, especially when combined with data on the built and natural environment and hazard events. So there are several actionable insights I'd like to point out. First, knowing which counties are stable elements of a migration system is key for disaster management planners. This information can be used to coordinate with local officials in the most likely destinations of residents of a specific county far in advance of an actual emergency. Second, the same information can be used by individuals who are considering moving away from a hazardous location and by communities that initiate buyout programs or want to plan for managed retreat. Knowing where community members have relocated in the past and being able to identify the safe neighborhoods or destinations within that potential set of destinations would empower people to move out of harm's way while at the same time minimizing loss of social and cultural capital and maximizing housing and employment outcomes by moving in anticipation of an event rather than in reaction to an event. Third, being able to measure the demographic characteristics of the movers in the migration system would provide us with insights into which destinations are being chosen by current movers and which may be best suited for future movers. So to summarize, I hope I leave you convinced that a migration system's data and set and approach can and should be used by interdisciplinary teams of researchers and community collaborators to facilitate adaptation to climate change effects. Thank you.
So thank you, Bess, for giving a really interesting and thought-provoking talk. I thoroughly enjoyed that. At this point, I would like to transition to the panel discussion. So to get us underway, once we have I'm going to invite our panelists to unmute themselves and turn on their cameras. Okay, so at this point, I would like to invite each panelist to give a brief take on the speaker's presentation. So I don't know who would like to go first. Pam, I'm going to put you on the spot.
Well, thank you. And thanks, Beth. That was a great talk. I must say that I felt like a data point in that presentation. I'm from New Orleans, and the little map, my house flooded, we rebuilt, we evacuated, all of that. And the point I'd like to make about that is one of the points that Beth was, I think, honing in on, is this idea that over the years when disaster scholars from New Orleans talked, most of us started with a sentence that said, I may have been flooded and lost my possessions and didn't come home for a while, a long while for many of us, but I stood in privilege. And I think that's a key part of where we think about these elements of the trends after a disaster, who goes, and the other question is who doesn't go, and then where do people go and how is that experience for them? So living through all that and through the cascading storms since 2005, we stood in a kind of privilege, because as Tony Oliver Smith talks about, after a disaster, the first thing that comes back is racism. And we saw that in policy with the road home. We saw it in opportunities for people to come home to a home when they destroyed all of the public housing units. All of those things happened. And so this idea that equity might be placed into this equation using actual data is really terrific. I mean, it's a really important piece of this work going forward. I'll go on later.
Thank you, Pam. Liz.
Thank you so much for the opportunity to join this event today. And I also really enjoyed Beth's presentation and learned a lot. It's early, it's in Japan, it's only 7 a.m., but I'm already like learning a lot. So thank you. Yeah, and I also appreciate Pam's comments about equity, so my background is housing recovery research. So I'm also usually looking at the household scale and kind of the individual stories and making the picture from that way up. So it's really interesting to look at it from the kind of like larger scale down. Yeah, so I guess my first one comment is I wonder about the, it's not really, for me, it's not really the event. It's more about how the policies are shaping things. So like, why did people evacuate? It's not because the hurricane happened, it's because how evacuation was managed or how support was provided or wasn't provided, or and then similarly, why didn't people come back? It's not because of the event, it's because were there opportunities to rebuild in the area, or was there housing provided nearby, or was there not? So and I think like, and those policy questions, like how are buyouts implemented? It's almost, the event is almost secondary to the main factors that I'm usually looking at. So I'm really curious if we get time to talk about how those things interact. And I'll stop there. Thank you.
Thank you, Liz. Sess?
Well, thank you. And thank you for a very interesting talk. Beth and I have talked before, and I think migration is one of the key things that we haven't fully understood in the context of natural hazards. So I'm a natural hazard risk analyst, and I work a lot on how communities evolve over a long term in response to natural hazards. And one thing that we've never been able to really get a good handle on is the migration part. And I think that last thing you mentioned, who moves, is really critical. And who comes back is equally critical, because what does this community look like over time? Well, part of it's a function of who's there. Part of it's a function of what policies do we put in place and how do those policies respond to what we see happening after the event. And I think looking at this, like Pam said, looking at the equities or inequities in both impact and in who comes back and in what ways and to where, I think is really critical to understanding how the vulnerability of communities evolves over time. And got lots more I could say, but I'll stop there too.
Yeah, fantastic. Absolutely. So at this point, I'd like to go to the questions that were submitted in advance. So I'd like to ask the panelists to weigh in on some of these questions. So the first question we got submitted was the following. What factors drive post-disaster migrations? Per capita deaths or injuries, structural damage, or something else? So I don't know who would like to start in trying to give an answer to that. Bess, why don't you try and give an answer?
I can say it's not deaths. I mean, deaths in the United States are from a disaster are pretty rare because we do have warning systems and evacuation plans. And, you know, while people do die in disasters, that's not driving the migration. I in my opinion, it's really a disaster is the damage that's done to the built environment, because the disaster happens when the built and social environment is overwhelmed by a weather hazard or some other type of hazard. The disaster isn't the hurricane, although that's how we often use the term. You know, we think of a hurricane as a disaster, but it's not. They happen all the time. If we build to be resilient to them and we prepare, then people don't, it doesn't turn into a disaster. So it's really the damage to the built environment. And the fact that like Hurricane Harvey had just as much damage, and if measured in terms of costs, as Hurricane Katrina, but you didn't see the population response. And that's a really strong evidence that something else was going on there. But being able to pin down exactly, other than the damage, what actually caused people to migrate is it's challenging. And I think there's probably a slightly different answer for every single event. And in New Orleans, I completely agree with Pam and Liz that it's as much about the policies and the political motivations and the resources devoted to recovery and the inequities and how those resources were distributed. I was also a resident of New Orleans at the time, which is how I got involved in this research. And it was just so, there was so much going on that could help us to understand what was driving people from not returning, because you have to remember that everybody left New Orleans. And that's really unusual too. If you think about other hurricanes like Hurricane Sandy in New York, there wasn't a complete evacuation, and so the dynamics of migration afterwards were quite different. But I'll leave it there because I want to hear what other panelists have to say.
Seymour, can I jump in?
Yeah, absolutely.
So one place where we've done some work is with inland flooding, so not coastal. And there's a body of literature there that suggests that perceived risk and perceived coping have a very substantial impact on people's willingness and ability to mitigate. It's not the same as evacuation per se, but then Pam, when you showed those results, that areas where you're seeing 7 or more storms, you don't see nearly as big of response. That's interesting, right? Because that's adaptation, but we see that in other data sets too. So just simple one, like we were looking at Google search volume right before hurricanes for generators. And in Florida, there's no appreciable response. In New York, before Sandy, massive spike. Well, it's evidence that, okay, well, they've adapted to this environment that they're in. But then you get these cases like Sandy, they had hurricanes there before, but this is something different, right? And I think that I think I'm agreeing with you, but it's something that's out of the ordinary that's going to maybe change their risk perception, change their coping perception somehow. I don't know what that is though.
I think that it's a really great question, by the way. There's a bunch of factors, but Seth sort of got at it. I think for people, and again, I'm looking at Southeast and Southwest Louisiana where I do my research, is people to return have to have the capacity to return, right? And that really that's a policy issue, in my opinion. You know, we send these people off with $20 to last for, 6 months while they're evacuated. But so it's the capacity, the individual and the family and the community capacity to return. But the other thing that we're seeing, especially in the consequence of Ida, is it's the people's faith and trust in 2 things. One, will their government, some government, really help them? And 3, how likely is it to happen again? So Seth, it's to your point, Ida for people in lower parishes in Louisiana is a real turning point. It is really a turning point for them because they've never seen it quite like this. And so I think it's a very good question and a thing to explore.
And Liz, I think you wanted to add something to that.
Yeah, thank you. So I'm in Japan, so we have more deaths after the tsunami. We have it's a kind of a different kind of event. So I'm sorry, I'm not familiar with the kind of direct correlation based on municipality and death numbers, but I think there might, when you get to these kind of mass casualties events where the whole town is wiped out, there might be other factors that we don't see so much in the United States. And then, yeah, I think kind of building on what Pam already mentioned about for me, it's also about the return, whether you're able to return or not return is really the kind of crucial question. And I think the factors, anecdotally, but sociologically also in terms of economic opportunity, are the jobs, are the schools open, are the kind of the factors. So beyond the built environment, it's more the network environment as well. And then I think the other question is time, like how long does the recovery take and can you wait for it to happen or not? And I think that's something that's not unique to the US, but also we saw after the Kobe earthquake where there's always winners and losers and rich folks are always fine and poor folks are never fine. And so there are communities in Kobe where people wanted to come back, and there was a land readjustment and street widening, so people were displaced, and then maybe similar to Katrina, but not to the same extent. Didn't have access to some of the information. It didn't have access to interim housing support to make continuity through the process. And then as the process takes longer, there's a natural process that occurs, which is folks find stability in a new environment. And I think place attachment is something that's beyond the scope of today's panel. But if you for a New Orleanian who the way that New Orleanians want to come back to New Orleans is something that's special and not universal, but I think that kind of desire to come back, but ability to come back or not come back. And I think that's also the case when you talk about managed retreats or folks who realize that they live in a risky area and maybe they would like to move, but they can't move, I think is another factor. So I should stop talking. Thank you.
Very good. Thank you very much. We do have another question which was submitted in advance. And this question I'm going to ask Tess to answer first, as it is kind of related to Michigan, and you've had some time here. So it says, how can Michigan prepare for an influx of climate refugees, given its unique climate positioning and ample space for development?
Sorry, my cat decided to come and see me just then. Well, Michigan, from a risk analysis standpoint for natural hazards, is not a bad place to live, right? We don't have the hurricanes, we don't have a lot of the big events, but how can we prepare for it? That's an interesting question. And do our existing policies allow us to prepare for it in some way? And I think it's a particularly interesting question because we don't know when it's going to happen, right? I mean, it's uncertain, like from Beth's talk, what causes people to migrate? Well, it's not every hazard that comes along. And I think we need to think through, and I think Pam and Liz can probably talk about this a lot more than I, think through, well, what level of support will they need? I think about how Japan approached the post-tsunami recovery is very different than how we do it in the US. Are there things we can learn from that experience, good or bad, so that we can do the things that work well and avoid the things that didn't?
I want to jump in here too, because that's a question that people in New England also ask for similar reasons. And, you know, I always point out that migration is normal. It doesn't only happen because of disasters. We move all the time. In fact, if everybody in this forum has probably moved at least once in their life, maybe out of their parents, I mean, certainly out of their parents' home, I don't know, maybe not, but often that if you've gone to college, you've moved over counties, you know, you've moved across states. And so migration is normal. And cities go through periods of growth and decline. And what I would say about Michigan or New England or any other sort of more temperate area relative to the South is that many people are predicting that, yes, that there will be movement back to these cooler climates. And how do you prepare for them? That's, you would prepare for them the way we are currently, like every city's trying to figure out, how can we become more attractive and improve our tax base or grow our tax base by growing jobs and building better housing. And that's the way places prepare for population growth. People plan for growth, and environmental migrants will be part of the migration system that happens during normal times. And they will be just like any other mover who's moving and looking for a decent house, good schools for their kids, good jobs, you know, a nice neighborhood. And so I don't know that there's anything special that needs to be done to prepare specifically for environmental migrants. Because I do think that they're qualitatively not that distinct.
So Seth, you had something you wanted to add.
So yeah, I was just thinking about this and thinking about what happened during the pandemic. I think one thing we have to be careful of is the infrastructure side. There's anecdotal evidence that during the pandemic, people moving out of certain areas and into more rural areas really stressed the infrastructure. So this is something that if cities have infrastructure that's near its limits, and if they're going to be on the receiving end of lots of people moving in for whatever reason, maybe it's economic development programs, that they need to think through that infrastructure ahead of time so that they don't end up with infrastructure that's not adequate for those populations. On the flip side of that, some cities have shrunken quite a bit over time and their infrastructure is oversized for what they have. So that would be, there's other issues on infrastructure condition and things like that, but at least size-wise, there might be something to grow into there.
Well, Beth, I kind of want to come back to something you said, because here I'm involved in a research project here that's asking receiving communities what their experience has been since 2005 to the present with movers, right? So this is in Louisiana, but this is also happening in Texas and Florida. And I think there are real critical questions to ask these communities ahead of time about what they're going to need if migration patterns shift, if people who can live through 7 storms decide the 9th one's too many, and where they go and who they take with them and what they'll need when they get there. But it's also a question for state policy in terms of how can they help these, like Shreveport, for example, someplace north, to make themselves, like you were saying, available and attractive to people moving, which is really going to happen as you're right, climate migrants are going to become another part of migration.
Okay, so I think at this point I'm going to ask the panel the last question because we're getting close to the end. So there was a question submitted, which is kind of related to this, and it says, post-disaster, there were opportunities for redevelopment. Do you think that where redevelopment occurred affected migration? So Liz, would you like to take a stab at answering that? Go
The
ahead.
answer is yes. And I hope my other panelists agree. I mean, I think going back to what I said before, we have winners and losers, and development is a big way that rich folks get richer and poor folks lose what little they had, unless it's done very sensitively and with equity with equity intentionally as part of the development program. Otherwise, yeah, people lose. And that's something that's not unique to the US at all. Like that's something we see all across Asia. And then sometimes it looks more, I don't know, evil is not an academic word, but it looks more evil when you have local folks displaced, policies that say, you guys are informal, you're living in a dangerous area, you have to leave, this is not safe, we're going to move you away, and you shouldn't be living here because you're illegal or undesirable or whatever. And then they're moved out, and then big resorts are allowed to come in and build. And that's something that we see everywhere. So yeah, thank you.
Would any of the panelists like to add anything to that? Okay.
Well, I would also just mention the role of flood insurance in that too, because that skews incentives all over the place.
Okay, so considering the time, I would like to go ahead and close the panel discussion at this point. I would like to thank our distinguished panelists, Saskia Kumar, Pam Jenkins, and Liz Maley, as well as our speaker, Beth Fussell, for her fantastic presentation today. I'd also like to thank everyone for attending. Please visit umsurface2society.org to explore our strategic directions.